Hello and welcome back to Ganesh Institute and in this series of linear algebra. So what is for today? We are going to discuss about how to find minors, cofactors and adjoint of a matrix so that we are able to find out the inverse of a matrix. So let's get started. Now if we talk about minors, let's say I have a matrix, let's say general matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. So these are as per the position of elements, right? Now if I have to find out the minors, what do we mean by minors? If I have to find out minor of 1 1 position, minor of A11, okay, then you need to hide A11, the rows and columns of A11 you need to hide. Whatever is left, just take the determinant of that. So this is the minor of A11. Okay. So can you see? Basically, when we find out determinant, along with minors, we write the position of element also, like the element itself also. We multiply both of them. But here, we are not using the element, only the rest of the part has to be considered. For instance, if I need to find out the minor of A22, for example. So minor of A22 will be, tell me. So you need to hide A22, rows and columns of A22. So whatever is left, that will be your, the determinant of those elements will be your minor. Okay, and how do you calculate determinant of 2 by 2 order? Just simply cross multiply, take minus sign in between. Correct? So this is how you calculate minor. So that means if we delete, if I need to find out minor of ij element, then you need to delete the row, ith row and jth column passing through that element aij, okay, of that particular matrix, and you will get the determinant. See, it is of order n by n. If the main matrix is of order n by n, then the order of the matrix you will consider for minor will be n minus 1, because see, this is 2 by 2 order. Correct? So then this is how you can calculate minors. Let's consider an example. Let's say I have 2, 4, 3, 5, a 2 by 2 order matrix. If I need to find out minor of 1 1, 1 2, 2 1 and 2 2. So 1 1 is, you need to hide first row, first column. Whatever is left is left. This is the minor. Okay. Then hide for 1 2, you need to hide first row, second column. What is left? 4. Similarly, you can do for the rest, right? If we need to do it for 3 by 3 matrix, let's say 5 4 3 2 1 3 5 0 6. So minor of 1 1 will be hide first row, first column. The matrix of rest of the elements need to take the determinant. 6 1s are 6, 3 0s are 0. So 6 is the minor. Keep doing it. You can find out the minors of rest of the elements. Okay. Now, what do you mean by cofactors? So in cofactors, we simply need to do, firstly, these are denoted by either C11 or A11, capital A11, A12, A13 for corresponding elements. Okay. So you need to have minus 1 raised to power I plus j. Okay, minus 1 raised to power I plus j. This is the position, number of rows, and the columns. Okay, the rows and columns. Minus 1 raised to power I plus j, and you need to simply multiply it with the corresponding minor. So for instance, this is minor 1 1, and if I have to find out cofactor 1 1, so I need to do minus 1 raised to power I plus j, that is 1 plus 1, multiply m11. What is m11? Which is 6, and minus 1 raised to power 1 plus 1 is 2, which is even, so 6 is the cofactor also. Getting my point? So this is how you calculate cofactors. For example, if you have to, let's take simple example. This is 3 8 minus 6 2, and you need to find out the cofactors. So a11, a12, a21, a22. How will you calculate a11? Firstly, this is minus 1 raised to power 1 plus 1, minus 1 raised to power 1 plus 2, minus 1 raised to power 2 plus 1, and minus 1 raised to power 2 plus 2. Then you need to multiply it with minors. So 1 1. 1 1 means hide first row, first column. What is left? 2. Then first row, second column. Minor is 8. Then second row, first column. Minor is minus 6. Then second row, second column. So minor is 3. Correct? Multiply. See, this is even. 1 plus 1 is even. 2 plus 2 is even. This is odd. So you will get opposite sign. 2 plus 1 is 3. This will be plus 6 and this will be minus 8. Rest the sign will be same. So 2 minus 8, 6 and 3. These are the cofactors. And when I have the matrix of cofactors, if I make a matrix out of this, so it is 2 minus 8, 6, 3. Remember, you need to write the right positions. A11 first, A12, A21, A22. Okay. Once you write the matrix of cofactors and you take the matrix of cofactors you are having, and if you take its transpose, then this becomes adjoint A. That means you know how to take transpose, right? I have already told you. So its transpose will be 2 minus 8, 6, 3. Correct? First row becomes first column. Second row becomes second column. Clear? So this is how you do in sense of cofactors. Let's try it for 3 by 3 order also, so that you have some confidence in solving such questions. Okay. Tell me, firstly, let's find out minors. M11. First row, first column you need to hide. So minus 3 ones are 3. Minus is in formula. Minus 4 ones are 4. So plus 4. That is 1. Right? Then M12. Correct? M12. You need to hide first row and second column. So you're left with 2041. Correct? Multiply. 2 ones are 2 minus 0. So 2. Similarly, M13. First row, third column. So you are left with this, -2. M21. Second row, first column. First column. Second row, first column, just bear with me. So if you hide second row, first column, what have you got? Okay. Second row, first column. So you've got -3, 4, -1, 1. Multiply. -3, minus is in formula, -4, so +4. That is 1. Similarly, M22. So you need to hide second row, second column. You are left with 3 ones are 3 and 0. Then second row, third column. Second row, third column. So you are left with 3 ones are 3, -3. Correct? Then you have third row, first column. Again, tell me. Okay, tell me. How would you solve it? So you have third row, first column. So I left with these 4. -12 plus 12, 0. M32. Third row, second column. So 4 threes are 12, -8. 4. M33. Third row, third column. -9 plus 6, -3. Correct. Once you got these minors, next step is to find out the cofactors, right? C11 or A11, A12, A13, A11. See, this is 1 plus 1, even. So value will be seen as minors. Cofactors will be equal to minor. Why? Because the formula is -1 raised to power I plus j minor. So if -1 raised to power 1, -1 raised to power even is there, 1 plus 1 is 2. So it will be equal to minor only. Now you have 1, 2. 1 plus 2 is 3. So -1 raised to power 3 into minor. This will give you -2. Correct? 1 plus 3 is 4. 1 plus 3 is 4, that is even. So the value will remain same. Correct? Then you have cofactor 2-1, cofactor 2-2, cofactor 2-3. Tell me, 2-1, odd, sum is odd, 2 plus 1. So sign change, -1. 2-2 is even, sign remains same. 2-3 is odd, change the sign. 3-1 even, remains same. 3-2 odd, so change the sign. And 3-3, please don't write M, this is cofactor. That is A, right? So A31, A32, A33. 3-3 is even, so sign remains same. So can you see, if we have matrix of minors, so we know odd positions are these. You simply, odd positions are these. This is 2, this is 1, 2, first row, second column. This is second row, first column. This is second row, third column, and this is third row, second column. Sum is 5, 5, 3, 3. Only these positions will be having different cofactors with opposite sign. Otherwise, rest all will be equal to the minors only. Correct? Now make cofactor matrix. So cofactor matrix 1 minus 2 minus 2 minus 1 3 3 0 minus 4 minus 3. Okay. Now when you will be having its adjoint, if you want adjoint, you need to take the transpose of cofactors. So make rows as columns. So this is first row. It will become first column. Second row, second column. And third row, third column. Okay. So this is your adjoint. Clear? Now, if I add one more concept into it, that is inverse. If you have to find out A inverse, that will be 1 upon A determinant adjoint A. And remember, determinant should not be equal to 0 because otherwise denominator will become 0. That means we need a non-singular matrix for it. Correct? You know how to find out determinant? You know how to find out adjoint? So this is how you can calculate A determinant. A inverse, sorry. Right? So for instance, what is the A determinant here? Tell me. You know what is A determinant? Basically, in A determinant, we need that particular element from any of the rows and multiply it with minors. Correct? Then A12 minors. A13 minors. Okay? So what have you got? A11 is 3. A12 is minus 3 and A13 is 4. So minus is here. Okay, multiply minor. What is M11? This is 1, 2 minus 2. So 1, 2 and minus 2. What have you got? 3 ones are 3 plus 3 2s are 6 minus 4 3s are 8. 9 minus 8 is 1. This is your A determinant which is not equal to 0. So yes, it is a non-singular matrix and we can go ahead with the inverse. Formula of A inverse is 1 upon A determinant which is 1 into adjoint A. Adjoint A we have just calculated here. 1 minus 1 0. 1 minus 1 0. Minus 2 3 minus 4. Minus 2 3 minus 3. This is your this is your inverse. This is how you can calculate inverse. Okay. If you really like this video, then don't forget to like, share and subscribe our channel. Till my next video, take care of yourself. Bye-bye.